Okay, so we're going to look at Lesson 8, Measures of Spread, IQR, and Box and Whisker plots. The measures of central tendency, mean, median, and mode indicate the central values of a data set. Often you will also want to know how closely the data clusters around these centers. The measures of spread, or dispersion, of data are quantities which indicate how closely a set of data clusters around its center. Just as there are several measures of central tendencies, there are also different measures of spread. The measures of spread would be interquartile range, which is IQR, variance, and standard deviation. So we'll look at all three of these, but today, interquartile range, IQR, and then box and whisker plots. Interquartile range. The range of data set is the difference between the highest and the lowest values. So if I'm saying to find your IQR, you would be looking, just get my pen to work here. You're looking at the range is the difference between the highest and the lowest values. This is not always a good indicator of spread because it only uses two values. And if you're using the difference, you might be using an outlier, which is skewing the data as it is already. So this could also not always be a good indicator, especially if you're including outliers and haven't eliminated them. Quartiles are data values that divide a data set into 4 equal quarters. So the median quartile, just change this here, the median quartile is Q2. So if you find the median, that's Q2. And we already know how to find our median from our previous lessons. That divides your data into 2 halves. So you have an upper half and you have a lower half. So the lower quartile would be Q1. That's just basically the median of every observation below the median, Q2. And then you have the upper half. So if I look at the upper half of the data, find the median there, that would give me Q3. Okay, so that's the upper 25% of the data. The IQR is the difference between Q3 and Q1. It contains the middle 50% of the data. Note that the list of values, this is really important, note that the list of values must be written in order from least to greatest before the quartile values can be determined. So if that data is not put from least to greatest, your IQR, your quartiles, is all going to be incorrect. The IQR is an effective measure of spread, but has limited usefulness. So calculating quartiles in the interquartile range. For a data set with n observations, after arranging the data in increasing order of magnitude, so least to greatest, the lower quartile is defined to be n plus 1 times 0.25. This would be Q1. The median quartile is basically finding your median, that middle number, n plus 1 times 0.5, that would be Q2. Another formula, same thing, is n plus 1 divided by 2. And the upper quartile is defined to be n plus 1 times 0.75, that would be Q3. Note that these are giving you the positions. Okay, so these are position numbers of where you can find Q1, Q2, Q3. So it's not going to give you the actual Q1, Q2, Q3. It's only going to give you the position number. And so you have to count through your data set. Okay, so you'd count through. So if my Q1 was 5, I'd count through my data set, go to the 5th position. That 5th number is my Q1. Important question, what happens? Sometimes you'll see this where you get a quartile that lies between values, some 5.25, 6.75. There are 2 ways you can do it. You can either average between the two, or you can choose the closest value based on the first decimal. And I'm going to do it that method. Choose the closest value based on first decimal. Okay, next that we're looking at is a box and whisker plot. And box and whisker plot basically plots your Q1, Q2, Q3 on a number line. So the box and whisker plot is a horizontal representation of the spread of a distribution of data. The box represents the middle part of the data between the lower and the upper quartile, and it contains the median The whiskers extend from the lower and upper quartiles to the smallest and largest values. Okay, so from your min to your max, basically. To construct the box and whisker plot, the data are plotted on a number line and the 3 calculated values are indicated. A box is drawn around the central half of the data, and then the lines are drawn extending your whiskers to the smallest and largest values to create the whiskers. A box and whisker plot, in addition to presenting some important measures such as median, upper quartile, low quartile, min-max values, also gives information as to how much variability is presented in the data, as well as the shape of the distribution. So symmetric, right skewed, left skewed. So an example here, I'm just going to squeeze it in here. Box and whisker plot, if I had some number line here, and it would look something like this, where I have 3 basically lines. This first line is your Q1. The middle, your median, is Q2, and this is Q3. I would draw a whisker out to my max value, and then a whisker out to my min. Okay, so that's a box and whisker plot. And you can also do that in Excel, of course. All these lovely graphs can be done using Excel. Determining outliers. So sometimes you will have outliers. Remember, outliers are values that maybe don't match the trend of your overall data. You have a 1.5 IQR rule. It determines the upper and lower tolerance values. So basically anything above or below those values would be considered outliers. So you can actually calculate it as opposed to just looking. Sometimes you would look at, say, a scatter plot and see what values are outliers, or you look at a data set, what numbers appear to be greater or less than the general trend of the data. In this case, you would be actually calculating it. So any data value that lies outside the upper and lower tolerance value is considered an outlier. So these, I know the spacing is not the greatest here, but these are your 2 formulas. Upper tolerance value is Q3 plus 1.5 IQR. Remember, this is actually the real observation, the real value, not the Q3 position. Okay, same with the lower tolerance. So if I took my Q3 value plus 1.5 times the IQR, the interquartile range, it would give me the upper tolerance. Anything outside of that value would be considered an outlier. Same for the lower tolerance, similar formula, except you're using Q1 value minus 1.5 times IQR. Okay, so anything beyond those are true outliers. So let's do an example here, constructing a box and a whisker plot. So example, the following data set represents the amount of marbles 15 different boys own. I have a data set here, and if I look at it, they're actually already in order for me, which is lovely, so I don't have to do anything there. I will number them though, so I can figure out 1, 2, 3, what positions they are. And don't confuse this with the actual data values. Those are just the positions they're in. So I'm looking at the median. You can just look through your data and find the median. I'm going to show you the formula. Remember, the median is your Q2. So Q2, remember the formula from the first page, is equal to n plus 1 times 0.5. In this case, n is equal to 15. I have 15 values here. So n plus 1 would be 15 plus 1 times 0.5. 15 plus 1 is 16 times 0.5. And therefore, this would be equal to the 8th data value. So if I look through, find my 8th data value, that would be my median here. So therefore, the median, which is also Q2, is 68. Okay. Let's do the similar idea here for Q1. Q1 is going to be n plus 1 times 0.25. And that's from your formula on the first page. So again, n is still 15 plus 1 times 0.25, 16 And that gives me 4. So that's the fourth value. That would be Q1. So the fourth value is Q1, which is 52. And then Q3, same idea here. Q3 is n plus 1. Now we're looking at the upper times 0.75. And this gives me 12. So this is the 12th position. So if I look at my data set here, the 12th position is 87. Therefore, Q3 is equal to 87. These are all the steps you should be following to be completing your box and whisker plot. We found our Q1, 2, 3. Doesn't matter what order you find them in, as long as you find them and label them correctly. Next, we're going to look at the minimum and maximum values. The min value is 18. The max value is 100. My data is in order from least to greatest, so it's not hard to find those. We're going to create a number line. Just a reminder here, I just want to go between this, but if you wanted to find, I'll do this on the side here, just if you want to find the IQR, I would do 100 minus 18. My IQR would be 82. You don't really need this just yet, but that's what you would do with that data. So we're going to create a number line. See if I can draw. I was going to try to do a straight line, but I know I also had issues with that before. So we might just be let's just draw it out. Okay, so excuse my line. I should have had a thing here, but it's not showing up. Okay, well, let's just go with my non-straight line. Okay, I'm gonna draw this line as best as I can, but I'm gonna draw a number line appropriate for your data set. You don't have to start at 0. In this case, my lower half is close enough to 0 that I can. I'm gonna start at 0. Actually, I don't wanna make my line as big there. 0, and our max is going to be 100. So I'm going to go up by 10s. And you want to keep it as consistent as possible here. On a test, I want you doing these by hand. You're not going to be using technology unless stated otherwise. So you do need to be able to draw these out somewhat accurately. So we have 0 to 100. I'm also going to add a title here. We have amount of marbles. And we're going to plot the median, lower quartile, upper quartile, and it's ideal to use a different color so we don't confuse it with your number line. So my lower quartile, my Q1 was at 52. So let's say somewhere around here. That's Q1. My Q2, which is my median, is at 68. And my Q3 is at 87. I'm gonna create a little box here. That's my box here. I'm also gonna label the values underneath so I know what they are. Q1 is 52. Median is 68. Q3 is 87. And then I'm gonna create my whiskers. My max value goes to 100. That is my max, and my lower goes to 18. already labeled. And we draw a line out to, there, actually let's fix this line here. Okay, ideally you should be using a ruler to keep this as neat as possible. I did what I could there with my technology. Don't forget your title. You want to make sure you label everything. You have your endpoints labeled, which go to your whiskers, your Q1, your Q2, Q3, their values. And a reminder, you don't always have to start at 0. And that's it for that part. Example 2. A random survey of people at a science fiction convention were asked how many times they had seen Star Wars. The results are shown below. Find Q1, Q2, Q3. The spacing on this lesson is a little bit off, but I'm going to put these in order here from least to greatest because they're not in order, and you have to be able to do that to get all your data values. So I'm going to write them out here. 1, 2, I'm also going to label, because this is going to help me when I'm finding my Q1, 2, 3. I'm going to label the positions. And it also helps me find my n. My n is equal to 20. I have 20 terms here. Okay, so now let's find our Q1, our Q2, and our Q3. So Q1, using the formula, n plus 1 times 0.5. We labeled n is equal to 20. And so 21 times 0.5 gives me the 10.5, so 10.5 value. So therefore, if I look at my values here, I'm looking basically at the 6th, because 10.5, 10.5, oh, sorry, I'm finding Q2 right now. Sorry, I labeled that as Q1, that should be Q2. Okay, so this is actually Q2. Is my n plus 1 times 0.5. Yeah, so I'm finding Q2 first. So Q2 is 10.5, which would be closest to 11. So I'm going to use this value here, the 11th position, which is equal to 6. That's my Q2. Now let's go to Q1. Again, doesn't matter what order you're in. I was going least to greatest, but it doesn't matter. Q1 is n plus 1 times 0.25. So that gives me 21 times 0.25. And that gives me 5.25. So that's a 5.25th position. If I look at that, that's closer to 5. So if I take the 5th position, it doesn't really matter in this case because 5 and 6 are both 3. It would be 3. So Q1 is equal to 3. And Q3 is 9.9. N plus 1 times 0.75. And that gives me 21 times 0.75. And that gives me 15.75. So it's a 15th.75. I'm going to use 16. So if I look at 16th position, that would be 11. Okay, so that's my Q1, Q2, Q3. Again, here for Q1, I used the 5th. And for Q2, I used the 11th. Okay. And that just goes back to what I was talking about here. What happens when you get a quartile that lies between the values? You can add them up, divide by 2. Here I'm just choosing the closest value based on the first decimal. Okay, so that's what you would do in case of the decimals. I'm now going to find my IQR, interquartile range. Take your max, which in this case, let's write Q3 minus Q1. And that gives me 11 minus 3, which gives me 8. Therefore, my IQR is equal to 8. Draw a box and whisker plots of the data. So if I draw a box and whisker plot, here my lowest value is 1, and my greatest value is 30. Okay, so you can draw a number line. And I'm going to go up by 5. It just would be most appropriate in this case because your values would be spread out between them. So choose an interval that goes up by an amount that will help you graph accurately. Okay, so those are all graphed there. My title would be Star Wars Views. And now we can plot. So it doesn't matter where you start here, but my Q2 is, just double check here. My Q2 is 6, my Q1 is 3, my Q3 is 11. So I can draw Q2 is at 6. My Q1 is at 3. Q3 is at 11. This is my box. And whiskers go to the max and the min. So my min is at 1. My max is at 30. And it gives you a good visualization of where and how your data is skewed. Okay. I just want that line to touch the box there. Okay. So now we have it labeled. We've given it a title, Q1, Q2, Q3, and we're good. So now let's take a test here and use the 1.5 IQR test to determine if there are any outliers. So the formulas that were given up here, your upper tolerance and lower tolerance. So we're going to take the real observations with those values. So our upper tolerance is equal to Q3 plus 1.5 times your IQR. In this case, our IQR was 8. So we're going to take the value of Q3, which we know was 11, plus 1.5 times our IQR, which we calculated as 8. So 11 plus 12, it gives us 23. So that would be the upper tolerance. Anything above that would be an outlier. Our lower tolerance, similar formula, but now we're subtracting. So we have our Q1 minus 1.5 times IQR. Our Q1 value here was 3 minus 1.5 times 8. 3 minus 12 will give us -9. So anything below that would be an outlier. So if we look at our data set here, our lower number is 1, so that's safe, that's good. Our higher number is 30. So therefore, we can say, using the 1.5 IQR test, that 30, so using the 1.5 IQR test, anything above 23 would be an outlier. Anything below -9 would be an outlier. So in this case, we can say 30 is an outlier. Everything else is okay. Okay? And that is your box and whisker plots, quartiles, and IQR.